Okay guys, today I'm going to help you get started on your Angry Bird project, and so in order to do this we're going to start by working out some of these problems by ourselves together, and then you guys will be working in groups to come up with your own project. Okay, so what we have so far is this is your Angry Bird project paper. It says red bird, yellow bird, blue bird, and black bird are angry with the pigs. The pigs stole the birds' eggs. The birds want their eggs back and will stop at nothing to get them back. The flight path of the birds can be modeled with a parabola. We're going to use x as the distance and y as the height. For each student in your group, you will be assigned a bird. Each member will answer the following questions for their assigned bird. You will answer what is the maximum height of your bird flew, what was the total distance your bird traveled, and then you will determine whose bird flew the highest and traveled the longest. And then you will also figure out which bird hit the following pigs located at these given points. Now, before we can get to actually answering these questions that go with the project, I'm going to demonstrate for you how to work through some of these. Okay, so if you'll flip your packet over to the first page. Now, this is the Angry Bird red bird that we're going to be working with, and this is in the first edition. So the red bird in each edition or each group's project will be a little bit different, have a different path, or have some different representations. For this red bird, we're given some specific things. We're given some important things right here. We are given the fact that the red bird has to start his flight from the point 10, 0. His flight path reaches a maximum height of 18 yards, and he lands at the point 38, 0. So all of these are important pieces of information. Okay, so to start off with, let's think about what we do know. What we've been given is some points. Okay, so I'm going to come over here to the side and I'm going to make a table of these points that we've been given. Okay, we've been given the points 10, 0. We've also been given the point 38, 0, which I'm going to put down here, and you'll see why in just a moment. And we've also been told part of another point, because we know the maximum height is 18 yards. And so if you remember back from the very first page, it said that our height is the y value. So one thing we know for sure is that there's some point in between where the bird begins and where the bird ends, the maximum or the vertex, the top, the highest point in this path, where the bird will go up to 18 yards. So we're still missing this x value though. Now we know that this is going to be our vertex because it is the maximum, so I'm going to go ahead and label that as the vertex. And in order to figure out what that vertex is, we need to find what's right in between 10 and 38. And in order to do that, we actually can average those together. We can add 10 plus 38 and divide it by 2. And when you do that, you have 48 divided by 2, which is 24. So we now know that our vertex is actually at 2418. So we have another important piece of information right here. Okay, now if we're going to want to graph this, which you are, you're going to need more than just 3 points so you can get a better shape of this graph. So we are going to actually want to find 2 more points, one in between where he starts and the vertex, and one in between the vertex and where he finishes his flight path. So we're going to be looking for 2 more points. In order to get those 2 points, we're going to need an equation. So what we're going to do now is we're going to move over here, and our next step is going to be to find an equation. Now the type of equation we're going to look for in this situation is going to be in vertex form. Now the vertex form is f of x equals a times x minus h squared plus k. So this is the type of equation we're going to be looking for. Now you might recall whenever you are trying to find a piece of an equation, there are some specific things that you can do to work your way around. Now we've actually already been given some of this information. We know that f of x is like what we're used to seeing as y. So I'm just going to recopy this equation with the y. And we've actually already been given the h and the k in this problem, because hk is our vertex. Okay, and we already know our vertex. We know our vertex is 2418. So we have the h and we have the k. And we can use one of the x's and y's from over here on our table, which means the only variable we don't know is a at this point. So we can find that a, and we'll be able to write this equation correctly. Now, if you recall from working linear equations, we've done something similar to that before. Like when we're trying to find y equals mx plus b. If we have m and we have an x and a y, we can plug in those variables. We can substitute in for the m, the x, and the y, and we can find the b. So here's an example where we plugged in a 4 for the m, 2 and negative 3 for the x and the y, and we solved to get the b, and then we rewrote our equation with the correct slope and with that intercept that we just found in that equation. Well, we're going to do something similar, but with this quadratic equation that's in vertex form here. So what we're going to do is we're going to go ahead and plug in what we know. I'm going to come over here and I'm just going to pick the 10 and the 0. So I'm going to plug 0 in for the y. And I don't know the a. I do know for the x that the x value is a 10. So I'm going to put 10 in place of that x. And then we're going to subtract the h, which is the x value of the vertex, 24. And then we're going to, at the end here for the k, we're going to have the 18. And again, that came from our vertex, which was 24, 18. We just plugged those in place. Okay, so we continue to solve this problem, and what you actually end up with is this right here. And when you square that negative 14, we have 0 equals 196a plus 18. Continue to solve for the variable. And a equals negative 9 over 98 when you reduce that negative 18 over 196. So it's a little unusual, but that's actually our a value. So what we now have is an equation in vertex form. We can just substitute back in the negative 9 over 98 in place of our a times x minus our h, which is 24, the x value of the vertex. That has to be squared, and then we're going to add 18. So what you have now is a vertex form of an equation that matches the path that this bird is taking, that red bird is taking. Okay, so we have a little bit more work still. We have this equation. We can now use this equation to come find some points that we can plug in here for our graph. Okay, so we're going to come over here and do a little more math. We're going to take and we're going to plug in place of this, some points in between. Now we know for sure, it might be nice to know what happens exactly between. It doesn't have to be right exactly in between 10 and 24, but I'm just going to go with that. And I'm going to go to 17 for the x value because that is 7 away from 10 and 7 away from 24, just to kind of see what happens in the middle. And then if I go again 7 up from 24, I go to 31. So I'm going to plug in what happens at 17 and what happens at 31 to get those points. So what I'm going to do is I'm going to be finding f of 17 using this equation. And then I'm going to be finding f of 31, again, using the vertex form equation that we now have. Okay, so plugging all that into your calculator and solving it, we end up getting 13.5 right here. And so we have 13.5, and again we had a 13.5 right here, which is expected that they will be reflected because they're equal distance from the vertex. So we have 17 and 13.5, and 31 and the point 13.5 as well. Okay, so we have 2 more points for our graph. And let me just go ahead and mark over here. Just a little reminder that our h and our k from this equation came right over here from this h and k that were in the vertex. And whenever we plugged in these numbers over here, that this x and this y came from coming over here and just choosing an x and a y value to plug right in there as well. Okay. All right, now we're just going to graph and make a smooth curve. Okay, and I've actually already graphed that for you. So right here on a piece of graph paper, you guys will need to do that yourselves. You will need to draw your axes, and you can see here that my axes goes out. I've marked every other box So my grid markings are by 2s, my scale is by 2, although you can see that I've only marked it by 4s. And so what I did is I plotted these points. I plotted the point 10, 0 where the bird began his flight. I plotted 38, 0 where he ended his flight. I plotted the vertex, which is 24, 18. This is the peak or the highest point of the flight. And then I plotted these 2 points that are in between that we just found so that I could draw a nice smooth curve and connect those together. And now let's go ahead and answer these questions at the bottom as well. First off, what is the maximum height? Well, obviously our bird flew 18 yards high, and you can see that that's the y value of the vertex. The axis of symmetry is right here where our vertex falls, where our parabola reflects, which is at 24. And then we can find the distance traveled. This is pretty easy. Actually, the distance traveled can be seen on your graph. If you see here, it goes from 10 to 38, and this is distance in yards. And so actually all you have to do is subtract where he landed from where he began, and you realize that there is a 28-yard difference. So our bird has traveled 28 yards altogether. And again, I'll just write that on here. We're getting that from these points, moving from 10, 0 out to 38, 0. Okay, so that basically completes the first part for Redbird. You've now graphed his path, and we have an equation and some information to go with them. And in the next video, you will try out another bird. Thank you.